7.3 Logarithms and logarithmic functions. A log is another way to ask a question. It's just asking what exponent do I need to get from a certain base to get to a certain number. So I have an example of a log written here, and we use log to represent log. I use the cursive because it just differentiates it between a 1 and an L, but you can write log however you want. Just make sure that you know that that's not a 1 in front here. And so we would read this log as log base A of B equals X. Notice that the A is written a little lower and a little smaller than it would be on the normal line. Make sure that your bases look like that as well. And what this base is doing, or what this log is doing, is it's asking a question. What exponent do I need to get from a base of A to get to B? Think of it as A to the what equals B, or I've got it written out in words here. A to the what equals B. There's written in math language. So I've got several examples here that we're going to take a look at and get us thinking in that mindset of log is just asking a question. What exponent do I need to get from a certain base to get to a certain number? In this first problem, the base is 2. So what exponent do I need to get from a base of 2? And I'm trying to get to 16. So the way that we're thinking here is 2 to the what equals 16. 2 to the 4th power is what would equal 16. And your calculator will come in mighty handy here in 7.3 if you don't know your powers, which is okay if you don't. You've got a great resource here. If you did not know your powers of 2, you could have just been typing in your calculator 2 squared, 2 third, 2 to the 4th, there's 16, so 4 must be my answer. Take a look at the next one. What exponent do I need to get from a base of 3 to get to 9? In other words, 3 to the what gives me 9, and we know that to be 2. So log base 3 of 9 is just 2. What exponent do I need to get from a base of 8 to get to 512? Again, if you don't know your bases, you're just going to use your calculator. Well, I know it's not 8 squared, but 8 squared, 8 cubed. Well, bingo, there's 512. So log base 8 of 512 must have just been asking for 3. What exponent do I need to get from a base of 5 to get to 125? In other words, 5 to the what equals 125? And that's just 3. What exponent do I need to get from a base of 2 to get to 16? In other words, 2 to the what equals 16? We just answered that one at the top. That's 4. What exponent do I need to get from a base of 6 if I want to try to get to 36? In other words, 6 to the what equals 36? And the answer is just 2. Now, what happens, though, when I'm trying to find the number instead of trying to find the exponent? Well, it's still asking the same question. What exponent do I need to get from a base of 5 to get to, I don't know. Well, the exponent that I'm using is 3. So it's saying 5 to the 3rd equals what? 125. If you kind of fill in what you know, you can be replacing these. And I'll show you in a minute here how to translate back and forth, which might make it a little easier too. I'm going to show you several different ways to deal with these logs. But the number one goal is that you're able to translate back and forth between logarithmic and exponential form, and you're able to evaluate logarithmic expressions. So what exponent do I need to get from a base of 2? And I don't know the number I'm trying to reach, but it says that the exponent is supposed to be -1. So I have 2 to the -1 equals what? And that's 1/2. What exponent do I need to get from a base of 10? And I'm trying to reach 1 over 1,000. Well, we know from 7.2 that when I have a negative exponent, that gives me a fraction. So I know that my exponent is going to be negative, and to get from 10 to 1,000, it would have to be -3. And again, you're just working on your calculator. You know that it's got to be negative because it has to go to a fraction. So 10 to the -1, math frac, that's not it. 10 to the -2, math frac, that's not it. 10 to the -3, math frac, there it is. Okay, so you can use your calculator as a great resource here. Log base, I don't know. It didn't give me the base this time, but it told me that you should reach a number of 81, and it told me that the exponent is supposed to be 2. So, kind of giving away answers here. Exponent is supposed to be 2. So, what number raised to the second power gives me 81? 9. What number raised to the fourth power equals 81? Because it told me to get to 81. It told me to use an exponent of 4. What number raised to the fourth power gives me 81? You take the fourth root of both sides, and it's 3. This time, what exponent's required to get from 16 to get to, it didn't tell me, but the answer is 3/2. So it said 16 to the 3/2 equals, well, you got a calculator for that. 16 to the 3/2, 64. Okay, so that's working on just being able to understand what a log is. Let's turn the page here and talk about a couple more things. So this might be very helpful for you to be able to convert back and forth between logarithm and exponential forms. So if I were you, I would pause the video and kind of write down the difference, because you are going to be asked to convert back and forth between logarithmic and exponential form. Exponential form, we have a base is our big number, here's our exponent, and it equals a number. Well, in logarithmic form, we have log, and our base is written down here, again, smaller and lower, the number we were trying to get, and it always equals the exponent. So you can either remember it like this, with the questions that we did on the previous page, or I have another way. It's called the loop trick. Now, the loop trick always goes from the base, and generally it's going to be counterclockwise, but it's always starting from the base, go around the equal sign, and end at the number next to the base. That will tell me the order to write it in the other form. So it started with the base. There's our b. The number that it crosses or passes by next is our exponent, and the number that it ends with is what it equals. So let's try out a couple of examples here. Write each number in exponential form. So let's try this out. Here's our base, and I'm going to draw my loop around the equal sign and end it at the number next to it. So 8 was my base. Next number, exponent, and it equals the number that it ended at, 512. Draw your loop, starts at the base, around the equal sign, ending at the number next to it. So the base, the next number it crosses is the exponent. The next number it crosses is what it equals. So you can do this either with what we had down at the bottom. There's the base, there's the answer and the exponent, and it's even color-coded to what it would look like in exponential. Or you can be asking yourself the question on the other side. What exponent do I need to get from a base of this to get to 512? We rewrote that in that form on the other side. And how the loop would work. If we were trying to go from exponential form to logarithmic, it works the same way. Start at your base, go around the equal sign, and end at the number next to the base. And that will tell you the order that it's supposed to be in. Log base b of a equals x. Okay, so let's try that example again. So it's in exponential. It's asking for it to be rewritten into logarithmic form. So draw the loop from the base around the equal sign and at the number next to it. So from the base, log base around the equal sign. So the next number that it crosses is 1331. And it equals the number next to it. Let's try it again. Base around the equal sign ends with a number. It's asking for logarithmic form. So log, there's my base. The next number that it crosses is 8. And it equals the number that it ends at. So let's evaluate with number 3. I've given you kind of a couple of different methods to evaluate. You can either change it back into exponential form and evaluate it that way, or you can be asking yourself the question, what exponent do I need to get from this base to this number? Like this one, for example, is asking, what exponent do I need to get from a base of 13 to get to 169? You can either answer that if you know it. I know I need an exponent of 2. Or you can rewrite it in exponential form. So I have a base. And this didn't have an equal sign, so we know that it's supposed to equal something. Base around the equal sign and at the number next to it. It's asking the same kind of question here. Either way, your answer is it's just 2. What exponent do I need to get from a base of 2 to get to 128? 1 over 128. I know that it's got to be a negative number. And I can just go onto my calculator and go, okay, well, I'm try 2 to the 5th, 2 to the 6th, 2 to the 7th. Oh, there it is. So it must be negative 7. Let's try it. 2 to the negative 7. Is that 1 over 128? And it is. If you rewrote that in exponential form, it would look like this. 2 to the x equals 1 over 128. It's all a matter on how your mind thinks. Last one here. So if I was writing it in an exponential form, it means it has to equal something. Here's my loop. Start at the base, around the equal sign, end at the number next to it. So 6 to the what equals 1. Or if you're asking the question, what exponent do I need to get from a base of 6 to get to 1? And the answer is I need 0. I'll give you a hint. Log base anything of 1 equals 0. Log with any base of 1 equals 0. The last little thing I want to talk about is this idea of a common logarithm. If you see something that has no base, and I'm sorry, that should say base after it, has no base, then you should assume that the base is actually 10. So for example, I was given log of 1,000. There's no base written here. You should assume that the base is actually 10. Anytime that there's no base written, it's 10. And we see that kind of understood or invisible thing several times in math. For example, if I didn't have a number in front of a variable, you know it to be 1. If I didn't have an index written, we knew that it was 2. And that's just kind of what we're dealing with here. The most common base in logarithms is 10, so they don't always write it. Log of 1,000 is the same thing as log base 10 of 1,000.